Everyone, welcome to the study of complex maths. This is the mathematics which is taught in that here. In this question, you are going to show that the function exponential complex of z is not analytic everywhere. F of z is defined as exponential. Instead of z, we express z in terms of x and y, which is x plus high y, where x is the real part and y is the imaginary part. The conjugate of f of z, you change the sign here. If it was positive, it becomes negative, and if it was negative, it would have become positive. And then we make use of Euler's identity, which tells us that when you have exponential x, you can express it in forms of cos and the sine. So expressing exponential negative iy in terms of Euler's identity, the result is cos y minus I sine y. Then we can express this function in form of function u and function v, where function u is a function of x and y, and also function v is a function of x and y. And u is the real part of this function, whereas v is the complex part of this function. Doing that, our function u will be the real part of this equation, which is exponential x multiplied by cos y. And the function v, which is the imaginary part of this function, will be exponential x multiplied by negative sine of y, which we can write as negative exponential x sine of y. Then from there, we take partial derivative of function u with respect to x. When you differentiate this function with respect to x, exponential differentiated with respect to x is exponential x, and the cos y is a constant. So exponential x multiplied by constant y, the result is exponential x cos of y. Then we take the partial derivative of function v with respect to y. When you differentiate this function with respect to y, sin y differentiated with respect to y is cos of y, multiplying by negative exponential x, and the result is negative exponential x cos of y. Then we compare what is referred to as Cauchy-Riemann equations. If the function is analytic, then Cauchy-Riemann equation is satisfied. And in our case, partial derivative of u with respect to x is not equal to partial derivative of v with respect to y. As you can clearly see here, exponential x cos of y is not equal to negative exponential x cos of y. And clearly, it means that the given function is not analytic everywhere. Also, we take the partial derivative of function u with respect to y, whereby now we differentiate cos of y with respect to y, which is negative sin y multiplied by exponential x, and the result will be negative exponential x multiplied by sine of y. Finally, we obtain partial derivative of function v with respect to x, and as you can clearly see here, our function v is this one. When we differentiate this function with respect to x, exponential x differentiated with respect to x, the result is exponential x multiplied by sine of y. And when we do that, the result is negative exponential x sine of y. We compare these two. Ideally, the Cauchy-Riemann equation tells you that partial derivative of u with respect to x should be equal to partial derivative of v with respect to y. So since partial derivative of u with respect to y is not equal to partial derivative of v with respect to x, then it follows that our given function is not analytic everywhere on the complex plane. If it could satisfy Cauchy-Riemann equation, then it would be analytical everywhere. But since it does not satisfy Cauchy-Riemann equation, it follows that it is not analytical everywhere. Thanks so much for your interest to learn complex mathematics for that year student. For more such learning, kindly remember to subscribe to this channel so that you don't miss a single video, since you will be notified whenever I upload it. Any suggestion, it is much welcomed from you so that we may keep on learning this important field of maths. Bye bye. See you in the next presentation as we keep on learning.